And we have a friend of NBIX with us today for our presentation. So without further ado, I'd like to introduce Shafraaz. Shafraaz is a registered architect and green building specialist, experienced in zero carbon adaptation strategies with over 26 years experience with sustainable design. Shafraaz is well known for his commitment to sustainable strategies and integrated community-based collaborative design, and has led community and stakeholder engagement and facilitation for many clients. He was the co-chair and a founding member of the Energy Transition and Climate Resilience Committee of the Council for Edmonton, where he helped develop the Community Energy Transition Strategy and Action Plan. Currently, he's the chair of NBIX, which hopes to freely share ideas, case studies, and expertise on how to achieve zero carbon architecture. So please join me in welcoming Shafraaz.
Thank you, Amy. Appreciate the introduction, and thank you all for coming to the post-lunch session. Hopefully, I'll keep you awake from your sleepiness induced by, high carbon or high carb lunches. I have climate anxiety. That's what I do. I now get all my news through the Beaverton because the regular news is kind of fake and garbage. But as you can tell by this slide, it's kind of funny but not funny how true kind of our world is in its disappointing action on climate and carbon, and much of it is a misunderstanding of why it's important. So does anyone want to volunteer a reason why we care about carbon? Yep, the greenhouse gas business and trying to essentially not create more than 350 parts per million of carbon in our atmosphere by a certain amount of time. Otherwise, we kind of trigger fundamental kind of ecosystem collapse. So with that cheery note, we also have to recognize we consume a lot of things that produce carbon. Believe it or not, water is a big carbon emitter because all of the energy it takes to purify water, to basically put it down the pipes and into our taps is quite a very big expenditure of energy and therefore carbon. And also the fact that we sometimes cool it, a lot of times heat it, also influence our carbon emissions, as you can imagine, through mechanical systems. And as an architect, a third of our carbon emissions are produced by buildings that we design and construct and build. And of course, if we create those emissions, we use energy. And obviously, if a third of the emissions come from buildings, almost a third of all the energy we produce is consumed by the heating, cooling, ventilation, etc. Of buildings out there. So I feel architects, engineers, designers have a huge responsibility to build better, to design better, to figure that out. And that goes for even construction, because half of our landfill waste is from all of the materials we utilize very badly, very inefficiently in the construction of buildings. I would love to do a whole other session on lean design and construction. There was one earlier today, but that's another passion of how do we, as an industry, think through and build and construct, and therefore hopefully do better in this whole aspect of emissions and carbon, and even the things we choose to build with has a huge influence on that, and that's the gist of my presentation today. So as I said, as an architect, we've finally, I would say only in the last 5 years, really come to terms with the problem we have created. And we are finally, as an industry, trying to do something about it. And a lot of that had to be because of regulation. So as many of you probably know, carbon and the former carbon tax we had is because of international agreements we have made, like the Paris Agreement, where we committed to stopping the emission of carbon by a certain date. And Canada is still committed, I believe, to a 2050 zero carbon action plan. And I have to say it's kind of disappointing, south of the border, they're kind of taking the opposite approach. So we are lucky that our governments and our industry are still somewhat taking this seriously, and we still have a lot of work to do, but we'll go from there. And I'm hoping people, especially the general public, kind of understand the implications if we don't stop emitting. Their insurance rates, I'm sure, are ratcheting up, and therefore there is not just the now defunct carbon tax that is an incentive to do something, but the fact that we have more and more disasters to deal with is going to make carbon kind of quite important to talk about and to deal with and to hopefully solve in due course. So what can we do about carbon? Well, first, who knows what the scope 1, 2, 3 emissions are in this crowd? Handful. Oh, good. Half of you, actually. Great. So some of you can help me out if I go astray. But essentially, what we're trying to understand and get people interested in is to really recognize where emissions are coming from, and they're defined in these 3 particular scopes and measured more and more so by companies that have ESGs or carbon action plans. So basically, we recognize our emissions comes from purchased electricity or purchased natural gas that we buy from utility companies. We actually combust that natural gas for heating and sometimes cooling, and that creates emissions. And then all of the indirect things we do in our businesses or in our activities contribute to the scope 3 sort of interrelated kind of emissions through basically activities we have to do that basically create those emissions, whether it's the actual construction of buildings or if it's the actual activities of our particular industries in detail. So as I mentioned, scope 1 is the direct emissions we create by running boilers, running air handlers, running natural gas furnaces that we are producing probably at the place of our business. Scope 2 is sort of that indirect emission when we purchase electricity that comes down the wires, or if we are buying energy for heating and cooling or having sort of a district energy system generally producing that. And scope 3 is all that indirectly related types of emissions that come from the products we create or the work that we do. And getting to carbon neutral is trying to really understand how all those work in our activities and how we can start to decarbonize or look at how we can fuel switch or we can transition to sources that don't create those types of emissions. And we've been mostly in the building industry focused on operational carbon for a very long time. And again, recently we've shifted that conversation to talk about the embodied carbon. And that is, as you'll see in a minute, sort of a very big focus of how energy efficiency has helped shift that around. So how does it all affect our industry in particular? As I mentioned, we wanted to reduce the amount of energy we consumed in buildings by trying to find energy conservation measures. We went to LED lighting. We went to high efficiency furnaces and boilers. We did pretty much all the low-hanging fruit. So basically, we tackled a lot of that operational carbon emitted by the ongoing utilization of buildings, but now we're shifting to embodied carbon, and really it's helping us to understand how we have to think of designing and constructing buildings differently through the material choices we make. Everything from structure to mechanical systems to even the finished products. And some of you probably know that we get some of that information through EPDs, environmental product declarations. But that, I think, is the journey we're on, is sort of making that switch to embodied carbon. As you can see from Architecture 2030, between 2030 and 2050, the whole embodied carbon aspect of our construction will shift to almost 50-50 between operational and carbon. And that's, again, because we have helped the energy efficiency equation reduce the operational carbon aspect. So where do we see embodied carbon? Everything from the extraction of the raw materials to the production and transportation of those materials and products, to the transportation to a construction site, the construction itself, and then the actual building through all of its embodied materials, and then also through the life cycle of that building. So we have this embodied carbon until we demolish that building, and even when we haul away all that material or we landfill it, it's still encapsulating an aspect of carbon. So when we talk about how we reduce the whole life cycle of carbon in a building, we're actually looking at the whole entire start to finish. And this now is relating to how we're trying to think about circular economies, and how instead of landfilling or demolishing, how we need to reuse materials or retrofit or to upcycle or to really try to take away some of that end-of-life carbon aspect. So what we do in the design world at the start is we look at that whole building life cycle assessment. We look at how all of those materials relate to mostly structure and mostly things that we identify right now as very big carbon challenges. So that is concrete and steel and aluminum. And actually, what we're beginning to also really consider is mechanical equipment and the refrigerants that sometimes cause a bit of problem when we tend to let those refrigerants escape into the atmosphere. There's several tools that we utilize. Probably a bunch of you have used One-Click LCA or know about the Athena Institute, who helped from the very start map out how to calculate carbon in our materials. And when you begin to really recognize where those materials really have carbon and operational versus embodied carbon, you begin to see how big of a challenge this can be. And I think in the last decade, we've recognized that we need to consider alternatives like wood construction for tall buildings. So much of the tall wood structures are because we are shifting away from the idea we have to build tall structures out of steel or concrete. It's the idea is the wood fiber itself encapsulates or sort of sequesters that carbon, and therefore is a carbon positive material that we have to work with, rather than a very high intensive carbon emitting material like concrete or steel, which frankly have magnitudes more of carbon challenges than wood itself. we are also seeing, because of good policy and good, frankly, regulation, and I know in Alberta regulation is kind of a four-letter word, but we're seeing certain places actually require us to identify the carbon emissions or quantities in their actual calls for proposals. So this is out of the township of Langley in BC. They particularly wanted in that RFP call for consultants who want to build in that community, you need to show us your carbon reporting for your work that you're doing. And I think we're a little bit behind in Alberta to reflect on that, but it will probably eventually catch up with us. So as I mentioned earlier, environmental product declarations are a really good tool that is sort of vetted by a third party to help us understand the material's carbon impact as well as other aspects in their use. And I would highly recommend that we all start asking our suppliers, like, do you have an EPD on the carpet or the ceiling tile or even wall coverings, and begin to make that part of our process in our design and specifications. I'm just going to go quickly through the city of Nelson a few years ago did a low carbon homes pilot to help builders identify where their carbon emitting or embodied challenges are. And as you can see, concrete is still the biggest by far chunk of that carbon emissions, over a third of it, followed by insulation, cladding, and interior surfaces. So as we know, most of housing is still built out of wood construction, but it's those darn basements we built. And that is going to be an interesting challenge as we try to find alternatives like glue laminated timber foundation walls, I hear, are piloting. Or I saw yesterday in a presentation sort of a encapsulated steel with styrofoam type of foundation wall that is created by Polycore. So we are beginning to help, I guess, solve this problem in carbon and the challenges we see through how we work through that and try to look at even still further and further. All of these materials have some aspect that we can do better on. So drywall, vinyl, carpet, even the tile we do, we start to have to question, can we find things as local as possible? Because sometimes the biggest carbon aspect of a material is in the transportation from afar, usually, or from even the raw extraction to the production to that whole chain of life cycle that incorporates. So just for example, if we think of flooring in housing, we tried to look at the emissions of each material, and it's almost kind of obvious, but the more natural a material is, the better it is for the environment, right? So if you see here, laminates and tile, they're kind of on the top end of emissions, versus natural linoleum or cork is kind of actually much lower. That said, I don't believe we produce cork in Canada, so we then have to look at where it's coming from to be able to say, okay, is this, even though the actual production of that material is low, how does it all stack up at the end of the day? And same with cladding. If we look at the different options we have, we definitely want to start to look at, hey, is there things that don't require a ton of carbon emissions in their creation, like clay plaster, or again, wood, or hopefully even hybrid cement fiber materials versus what we know, things that generally require big kilns or big furnaces like brick and aluminum or steel panels. They're surely the most carbon intensive we have to do. I wanted to also mention again back to mechanical systems. I was curious if any of you run into challenges with refrigerants in speccing mechanical systems, because a project we did as a net zero commercial building using VRF mechanical systems now needs to think about what type of refrigerants it can utilize going forward or in future designs, because the refrigerants, for example, are now being regulated to be less of the type that creates the high global warming potential. So we know that even though we create some solutions where we can create better, more efficient mechanical systems using variable refrigerant volume and heat pumps, it's really, really tricky to now really get the right installers to produce these systems and not create challenges when something leaks. So this will be an interesting kind of thought for the next little while. I'll go through a quick impact of materials through the International Olympic Committee, who were looking at materials, particularly signage, and how wayfinding and signage and branding kind of has that impact as well. So they basically followed sort of a European standard of considering embodied carbon and operational carbon in looking at how they then look at all of the things they have to put up for temporary events and going, all the signage boards, all the graphics, all of the electronic signs, the flooring, the self-adhesive stickers and decals, all have an impact and all have a material quality that they're like, hey, can we be a bit more smarter about how this can work? And so again, much like a building, they went through a whole, how do we design something that thinks through the building life cycle, thinks through where it's manufactured, where it's supplied from, where it's even printed, because they went through even the idea that the inks that we use to print signage is challenging, because a lot of them have chemicals that not only off-gas, but create human health hazards. And then what to do with all the signage at the end of the Olympics where they become defunct or not necessary? Is there a way we, instead of landfilling them, can we upcycle or put them back in a value stream of some sort? So they looked at how that whole printing process can now hopefully take more water-based solutions or solvents that are far more friendly and don't create dioxins in their production or don't create challenges but are also UV resistant and able to capture those. One of the things we sometimes think about, but not often enough, even in our building materials like carpets and wall coverings, is flame retardants, and same with signage. So they started to study how flame retardants are very problematic. Many of them have phosphates and chlorine and other toxic chemicals that go into their production, and they're forever chemicals. So essentially they're going to be around and through the ecosystem and through our water cycle and on and on and on if we're not smarter about these types of things. And I can't present without going into PVC and the challenges of polyvinyl chloride, and especially for a long time, especially in the building world, we've known about off-gassing of PVC and the very challenging production of PVC and the inability to actually recycle PVC as a plastic. So we, as specifiers, are trying not to utilize PVC as best as we can, because not only is the carbon impact challenging, but it's also in many jurisdictions, especially in Europe, it is now becoming a banned material because of the processes involved in creating that type of material. So on one hand, we look at trying to use laminate flooring, but on the other hand, is it made out of PVC? Great. So use linoleum instead is the idea. With the Olympic signage kind of study, they began to really say, hey, why don't we actually use digital signs rather than print stuff? Because in certain cases, this will solve a lot of the challenges in the visual wayfinding and things that do not then need to be thrown away at the end of its life. So I think there's lots of work to be done in how we look at alternatives and solutions and think differently about the products we choose. Switching back gears to buildings and building construction, we were very fortunate to work with the Canadian Wood Council on a project that, again, helps architects and engineers reconsider the materials for structure and envelope for very common commercial buildings. So we were asked to, not look at CLT or glue lams, but look at actual dimensional lumber as solutions for a couple of very common building types. For example, large warehouse buildings that have an office component. So the top two slides, the middle and the top, are this idea of how do we construct these very large manufacturing or industrial bays that actually builds trusses out of 2x6s or 2x8s of dimensional lumber rather than having to get glulam beams and columns. So this was the whole study, and there are actually really neat ways to build trusses out of very small pieces of wood that can solve our challenges. The bottom slide is another very ubiquitous building type, the commercial retail unit, or CRU. And again, we did the same exercise where we helped, working with a structural engineer, develop a CRU that is most commonly using light gauge steel construction today, but we used an all wood type of system to be able to show this is possible. We can create these trusses and very simple structural solutions, even seismically challenged areas that can take into account shear walls and so forth. So I think the fun part of being a designer working with low carbon materials is trying to push the boundaries of materials we know are out there and what we can utilize to really help solve that challenge. This is going to be sort of the last project I want to share with you. It's a couple of fire halls we're developing with 546 architects out of Winnipeg for the city of Edmonton. And this is where we were able to help guide the material selection due to that life cycle analysis of where things were. And having practiced in architecture a while, we were trying to just encourage a lot of different ideas, but also testing how far we can really push simple materials and simple forms to do something spectacular. So generally, I think as designers, we want to be more expressive, but there is a simple elegance to materials as well that also means we can be smarter about carbon. The less complex and layering of materials we have in a building envelope or a building design, the better off it typically is, because the less waste it creates, or the simpler the connections are, the easier it is to deconstruct or disassemble those materials and reuse them again. So we worked with the design team and the owner and the end user to say, how do we best make this fire hall kind of speak architecturally, but still have a sense of scale and materiality and texture and elegance and cost effectiveness as well as carbon. And so we were trying to help the design team really understand and choose the right type of materials based on how they are detailed, how they are shipped, how they are basically even put together. So again, here you see avoid creating these different notches or articulation in buildings that make a lot of cutting and a lot of junctions and therefore challenges in those transitions. How do we find materials that are robust but also durable and cost effective? So and brick, unfortunately, was something we were trying to like dissuade them from, but frankly, there's a lot of existing fire halls in Edmonton that have used masonry. So the end users were pushing for something that was a little bit more traditional in that. There is very few solutions for the overhead doors for fire halls. So how do we start to look at the relationship between metal and other materials that can kind of work to our advantage? So here are some renders where we tried different aspects and colors and textures to be able to test that out. And then the architects kind of went awry and started to get interested in corrugated metal materials or the things that would add that texture. So again, we helped understand, okay, if we're going to source materials, where is it produced and how can we be effective in its assembly? So don't go to Europe to get all of this fish scale-like material, even though it's durable and lightweight and malleable, but is wildly cost ineffective, but also has challenges with other durability issues, including how things oil can or how they dent. We did a presentation yesterday on climate risk, and what we're also reminding architects and engineers and even our end users is that the hail that we will have in our region is going to damage buildings more and more and more as we get more extreme events happening. So how do we start to then say, how do we make these robust? So the corrugations, the type of material can actually create the rigidity and avoid that if we are smart about it. So, or if we are going to select steel as a building material, that gauge of steel has to be very carefully determined. And again, steel is a high embodied carbon material. So how are we going to offset that with something a little less carbon impactful? And then they got ridiculous. They got, can we use expanded aluminum or this? It's like, no, you're not using that aluminum. It's way too carbon intensive in terms of its type of thing. So we have to start to restrain ourselves a little bit, but also be flexible, I guess. And so as we all know, everything in moderation is probably the best solution. And essentially, what we're trying to do right now, looking at fiber cement or things that are locally available, locally good for our environment, but also our climate and the particular challenges we'll see in the next little while. So essentially, how we think through these materials are sort of the team effort it takes in working with even our life cycle analysis. We used one-click LCA to do all of the embodied carbon accounting, and therefore presented a lot of the analysis of how they can start to pair them together and to be hopefully smarter and more effective with that. I will stop there and see if there's any questions, comments. Yes, Frank.
Going back to your decisions, I guess, did you come up with a decision that was the best? Because it's never just one priority. It's like there's a bunch of overlapping circles on priorities.
Oh, totally.
So maybe for that fire hall, what did they end up with? And
It's
maybe for the fiber cement one, fiber cement's got some pretty big error bars on pluses and minuses. Have you found the fiber cement? Everyone knows that James Hardy, have you found fiber cement that's on the lower, or what's that lower range one?
well, there's Canadian fiber cement products like CanXL that we're considering. But again, the thickness and the long-term durability, when you look at the entire life cycle cost, like if it had to be replaced, is somewhat problematic. So right now, we are actually considering precast concrete panels because the precast will be locally produced and we can start to actually utilize low carbon concrete mixes. So working with companies like Heidelberg Materials and being very, very careful about the specification of that is sort of where we're landed at the moment. But we'll see how that comes through. It's still in we're working through the design right now on that. But that challenge is, like I said, concrete is a very, very, very large carbon intensive material. But I guess how do we balance that out with the overall effect architecturally, but also the durability? And the fire department is actually very interested in showcasing non-combustible materials as a direction in their view of how they need to show leadership in sort of being climate resilient. Good question. Whereas,
I have a question. I think it's going to be too complicated to make a decision from architect and get the material you want it to be low carbon or so. You're talking about, for example, fiber cement material. But when it's come to the construction, trade and construction company coming to owner and say, okay, if I do it without video panel for you, combine the metal cladding, you are going to spend, for example, $20 per square foot less. It's going to be saved you the big building $2 million. That's a sort of challenge and headache. I'm looking at $2 million, you want to save challenge and alteration. Is there any approach to make, because it's happening, and it's happened for us all the time.
yeah, what we do and what I like to promote is the tool called choosing by advantages. So we basically understand from our end user and our client, what are your priorities or what are the must-haves, and let's tabulate what those are and give them sort of a weighting or a ranking. And basically, if we're going to look at alternatives of materials, we always utilize choosing by advantages to understand how they stack up against the weighted requirements or priorities you told us in the first place. And that helps create a more objective decision-making process. And it also shows sometimes the least cost solution is not the best long-term or best value solution for all of the priorities they want over the long term. And so, and that's especially why we do life cycle analysis, is to show, hey, the replacement cost of very low gauge metal panels, even though their first cost, the least expensive, we expect hailstorms to probably destroy that, and we expect those to occur in the first 10 years. You're going to be replacing this material more often than you think. So it's being able to show that analysis and that ability to choose by the value set or by the requirements we have all agreed to at the start. Yeah, at the.
I'm actually the manufacturer of the polypore system you mentioned earlier.
Right.
And we are chosen a lot of times for lower carbon level compared to basement foundation walls and floors, which we do without concrete. But when it comes to above grade walls, we run into time and time again where the people that are calculating the carbon claim that the wood in the walls gives them a carbon credit rather than a carbon charge. And I'd just like you to just maybe speak on that. I mean, how can you, over the entire life cycle of the wood material, which at some point is going to be landfilled or rotted or whatever down the road, how can wood be given a carbon credit versus other materials?
Well, I think it's the sequestration of the carbon in its actual, like the raw material itself.
During the middle of the life cycle, what about the end?
And I guess that's sort of where you have, like when we do LCA, we do them by a certain number of years. So for a residential building, we would probably assign 40 or 50 years of life cycle. And it's very rare that we would account for the replacement of a wood structure in that life cycle.
Would plastic not fit into that because it doesn't degrade at all?
Yeah.
And yet plastic has a carbon charge.
Yes.
Wood has a carbon credit.
I think your challenge is in the actual data that's embedded in these carbon calculators that say wood is positive, plastic is negative, because it doesn't, and that fundamentally is probably where we have to rethink or think that through a little better, is sort of, hey, how do we account for something that will never actually degrade? So I think that's a flaw in some of that system. Fair point. Yeah.
Could you go back to the wood, using wood where we normally use steel studs in those commercial buildings? How did you look into getting around the fire code requirements?
Yeah.
Was drywall good enough, or what did you do?
For sure, especially in these larger warehouse type buildings, we had basically we had to look at the building code to say, hey, this is medium or low hazard industrial kind of utilization. So in those cases, you would actually have to build a firewall between the office component at the front, which is a different occupancy type, and the medium or light industrial use in the back. And that firewall is sort of how we determine, yes, we'll need extra drywall, in this case, including insulation or other types of barriers. So it was really, it's whenever you have a mix of occupancy types in this type of building that created the firewall or fire rated challenge. But if you have a very large space that's designated as an industrial, you can utilize the wood structure without an issue, because roofs are not requiring a fire rated assembly, because there's nothing above them. But if you put a floor above them, then it triggers certain aspects. So yes, it's a careful balancing of how you define the occupancy and where you create fire compartments or firewalls. But in our code analysis, it was very clear on how to do that. The interesting thing on CRUs that probably people don't recognize, As soon as you put a daycare into a CRU, that triggers a whole other firewall type, because the building code identifies that kind of childcare space that requires far more fire protection from the rest of the bays. So that was interesting, and that's sort of where we were helping developers understand, if you're gonna think you're gonna rent or lease this out to a childcare facility, try to put it on the end of that wood structure, and then you can, again, compartmentalize that separately from the rest, so it's not too expensive. But yeah.
3 buildings?
These are part 3 buildings, yes. Any other questions? All right.
Good question, talking to your people from, suppliers.
Yep.
So, lots of them challenges with providing EPD.
Yep.
And sometimes when you're reaching out to them and asking for platinum lead project, I need this kind of material. So, you provide me what percentage of recycle you have in your material. They cannot do that, or if they wanted to do it, just saying your price is going to be higher. Why? Because this material I'm getting is the source from, for example, China, and doesn't have any background how much recycled, how much is not. But the other material I'm getting is resource from US, and it's more expensive. So, this is a kind of big challenge that we will have in working with suppliers.
Absolutely, yes. I've actually been in that spot. In fact, the example I can think of is steel. For a long time, we were fighting to get Canadian-sourced steel in projects rather than steel from Korea or China. And it was like, well, we're able to make that choice by now having to specify how the steel is produced and the amount of recycled content. So Canadian steel, believe it or not, is coming from not blast furnaces, but arc furnaces, which are far better and far more environmentally and energy efficient than the blast traditional furnaces. So that is one aspect of like how, again, in light of not having an EPD, how to start to differentiate and how to then compare these particular choices is like, okay, we have to start to ask how things are made. Because sometimes the transportation doesn't show that carbon intensity because it's on a ship or it's on a rail car. So there are other things we have to identify as aspects to it. The one thing I would also love to talk about is the just and the equitable labor that goes into material production. That's a whole other discussion and vetting. So we're starting to ask suppliers like, hey, does your labor actually, is it humane? Is it non-forced labor? Because believe it or not, that's a thing. And there's actually a few groups now that are actually presenting cases of how to now look at where we source and specify materials to make sure it's not by said forced labor places. So lots of issues in the world. So
Could I just ask an ignorant question?
totally.
I don't know a lot about this. I find this very interesting.
Okay.
The complexity of all of these questions frankly overwhelms me.
Yep.
It seems like this simple, straightforward answer, rather than suggesting that I do a mountain of research that I know nothing about, the simple solution is regulation. Yes.
Can be, but in certain jurisdictions, like I said, regulation is not liked any as the option. But I think there are professionals that kind of do this type of work to help the building industry out there. So our practice in sustainability is basically just that, is to help the design team make these recommendations based on the knowledge we have and the research we've done, and the tools we can bring or to share with you, like that one-click LCA lifecycle tool, or for example, going right to basics, the Athena Institute, and looking at some of their research and papers on how to choose materials. So, yeah, there are consultants for that.
Yeah, and
But-
my competitors may not choose to go down that road, so.
Right.
It's a tough one.
Yeah, but I think even architects and engineers are beginning to have that as direction, either through their owner's project requirements, saying, hey, you have to follow these carbon reductions action plans we've created, and show how your choices are in line with our policy. So it's not as hard as you think. It is a steep learning curve to sort of get through the first initial understanding, especially now with embodied carbon. But yeah.
Sorry, I'm just sort of dominating this question. So where do I start? With my architect?
Yes. And ask if they don't know, they can hire, shameless plug, hire me to help you figure that out. But, sorry.
Is that the 2030 code that's going to address embodied carbon?
The code is changing. So yes, right now we're trying to have enough step code for energy, and eventually that energy also will relate to carbon. So yeah, by 2050, our country needs to figure out how to become zero carbon in all we do. So I would hope so. And again, building codes, frankly, take a very long time to get their shit together. But, well then, I think I'm almost at time, but any other questions? Cool. Well, thank you so much for coming to this, and hopefully you learned a little bit. Pleasure.